Hello dear students, this is your Jagan sir. Welcome back to our YouTube channel Physics with Jagan sir. And we have successfully completed 8 chapters, 8 different concepts on Newton's laws of motion in this chapter. And today we are going to see friction. And friction is actually, it's a huge and one of the typical topic. So we do one thing. Here today we will discuss a little bit concept about friction, and after that we will discuss some basic problems on friction to get you very comfortable, very knowledgeable on the friction. Today's my class, and application orientation we will see in our tomorrow's class. Right? Applications means how the critical problems will be framed from the friction topic that we will see in our next means tomorrow's class. And today, first of all, what is friction or frictional force? Friction and frictional force. See, whenever an object is placed over other object, and this object is trying to move in any direction. Like suppose this object is moving in the forward direction, right? Now a force will develop because of the roughness present between the two surfaces. A force will develop. That force is trying to oppose the motion of the object. Trying to oppose motion of the object, right? That force which tries to oppose the motion of the object is known as frictional force. Frictional force. Frictional force, right? And we will see a case. Does the frictional force remains act in every time opposite to the direction of motion? That we will see just now, because most of the students are getting this confusion whether the force or any object, if it is moving in a particular direction, does the friction remains always in the backward direction? Is this is the correct statement or not? That we will see in today's class, right? And before that, I would like to tell you, friction is such a force which tries to oppose the motion of the object. Clear? Then see here, friction is of two types. Number one is static friction. Static friction. What is static friction? Static friction means, suppose an object is present here. Suppose an object is present here, and see, even certain amount of force is acting over this object. Certain amount of force is acting over this object, but the object is not moving in any direction. That means here a set of force is present. A set of force is present that is opposing the object to move in the forward direction. Even some amount of force is acting. This force which tries to make my object to be at rest or at stationary position, even some amount of force is acting on the object. That force is known as static friction. Static friction. This is what is static friction, right? Then second point, but by the application of force, unfortunately the object is ready to move, or the object is starting its motion. It is moving in the forward direction. Even when it is moving in the forward direction, or in the direction of application of force, because object force is acting in the rightward direction, so object definitely will move in the rightward direction. Now, when object is having some motion with respect to the ground, definitely a frictional force will develop in the backward direction to oppose its relative motion with respect to the ground, right? That frictional force is known as kinetic friction. Kinetic friction. Kinetic friction. This is first of all what is static friction and what is kinetic friction. I hope you are very clear over this representation, right? Then see here, direction of frictional force. This is one of the most important part. Direction of frictional force. Direction of frictional force. See here, the first point is, suppose an object is placed here. Over this object, certain amount of force is acting. Obviously, friction force will oppose its motion. It's very fine. It's quite natural. I hope you are very confident on this concept. But if we are considering a situation, in this situation, let us assume Two blocks are present. Let this one is having velocity v1, this one is having velocity v2 with respect to the ground. With respect to the ground. See, if the observer is on the ground, if observer on the ground, right, observer on the ground, if he draw the free body diagram, it is moving in the forward direction with the velocity v1, means obviously friction will act in the leftward direction. Friction will act in the leftward direction. Similarly, for this object, for every equal action, opposite reaction means the same amount of F1 will act on the lower block because of the upper block, and here V2 is acting in the sorry, and V2 is acting in the rightward direction according to the question. So obviously friction will act in the leftward direction. Friction will act in the leftward direction. Right? Now, and this is when observer is on the ground. Now, let us see a special case when observer on the lower plank. On the lower plank. See here, if observer is sitting here, according to him, velocity of first plank with respect to the second plank is velocity of first plank minus velocity of second plank. Right? Now, can I say it is moving with the velocity v2, it is moving with the velocity v1, moving with the velocity v1. Now, can I say he would feel that first and for for v2 is greater than v1, v2 is greater than v1. Now let us see, suppose let v1 is equals to 3 meter per second, v2 is equals to 7 meter per second. Let us assume like this. Can I say now 3 minus 7, which is equals to minus 4 meter per second, minus 4 meter per second. What does it mean? That means he will feels that this observer feels that this object is moving in the backward direction with the velocity of minus 4 meter per second. Am I right? Velocity of first object with respect to the second object. That means with respect to him, this object is having negative velocity, means it is moving in the leftward direction with the velocity of minus 4 meter per second. Am I clear, beta? Am I clear? Right. Now, if the velocity is moving in the leftward direction, means obviously friction will move in the rightward direction to oppose its relative velocity. So, next point, if F1 is moving in the rightward direction, means for every equal action, opposite reaction, this one again F1, this one is again F1, and similarly this is having V2, and again here F2 will form. But did you notice one point here? Originally it is moving in the forward direction with the velocity V. That V value we consider as 3 meter per second. This is actually with respect to the ground, and this is we considered 7 meter per second with respect to the ground. And here you notice one most important point, even the object with respect to the ground is moving in the forward direction with the velocity 3 meter per second, but still the friction is acting in the rightward direction. Did you notice this? Right? But if the observer is on the ground, the friction will be leftward direction. This is one of the most important representation of the friction. Right? I hope I am very clear from my side. Let us see some numericals over the same concepts which we were covered so far. Right? Chalo. Number one. And these are the very basic problems. Today we are discussing very numerical, very basic problems for getting your clarity on the subject. Right? Now, number one, a block of mass 1 kg. Right? And one more point I would like to tell you. Calculation of friction. Here, you must remember a formula. Friction is equal to coefficient of friction into N, normal force, and this mu will be sometimes kinetic friction, coefficient of kinetic friction or coefficient of static friction. That depends on the situation that we will cover in our numericals very clear, very clear. That's I am promising. Right? Now, let us see first question. A block of mass 1 kg is sliding on a rough platform with velocity v is equals to 2 meter per second. An external force F is equals to 1, right? F is equals to 1 Newton, 1 kg, and v velocity is 2 meter per second, right? An external one acting on the block as shown in the figure. Find the direction of kinetic friction force on the block exerted by the ground, on the ground exerted by the block. And see, for your clarity, the object is having velocity in this direction, so friction will act in the leftward direction. Leftward direction, because object is moving in the forward direction means relatively it is trying to move in the forward, so friction will act in the leftward direction. Never consider the direction of force. Direction of force, direction of motion is important. Direction of motion is important. Most of the students are considering F and immediately they keep friction in the opposite direction to the force. It is not correct. And number 2, on ground F is acting in the rightward direction. I hope I am very clear, right? And next one is second question. Second question. Two blocks are moving on a rough platform with different velocities as shown in the figure. Right? Number 1. This is moving with a velocity of 2 meter per second, and this is moving with a velocity of 4 meter per second. Right? All the surfaces are rough. Find the direction of kinetic frictional force on each block at this instant. What is the direction of kinetic friction forces? See here, this is having 4 meter per second. Obviously, kinetic friction will act in the leftward direction, and similarly, here also kinetic friction will act for every equal action, opposite reaction. Here it is moving in the forward direction F2 for the observer who is on the ground. This is what just we have seen, right? And obviously its velocity is higher compared to this one, and relatively this one is moving with a more velocity of 2 meter per second with respect to this block in the same direction, forward direction. So obviously friction will act in the leftward direction. Clear? Right. Then third one. A block of mass m is placed at rest on rough inclined plane. Is there any frictional force acting on the block? Yes. Draw the free body diagram of block and calculate the frictional force acting on the block. And remember, drawing free body diagram is one of the most important topic which we have already covered so many days back. And see, here a block is present. This block is originally having mg in the downward direction, and here theta means, and remember again and again I am saying, how can we draw the free body diagram, how can we represent the force directions here. See, if it is theta means obviously this one becomes theta, so this becomes 90 minus theta, again this becomes theta, this becomes 90 minus theta, this becomes theta, this becomes 90 minus theta, this becomes theta, this becomes 90 minus theta. This is one of the most important representation. Everyone has to be very strong in this representation. Number 2, this is mg, it is making an angle theta means this will be mg cos theta component. And this one is also we have seen in our vectors chapter very clearly. If you are interested, please go back to vectors chapter. There you will get the required amount of knowledge. Then its 90-degree angle will be mg sin theta, and relatively the block will try to move in the downward direction. Obviously, it will try to move in the downward direction. So friction will act in the opposite direction to the direction of motion. And next point is, this is n. So frictional value is mg. Otherwise, if you want it in depth on inclined plane, set of all the forces acting is equals to ma. Suppose it is moving in the downward direction with an acceleration a. Let us assume like this, right? Now set of all the forces acting on the inclined plane means and object is obviously moving in the downward direction, so I have to consider downward direction as the positive. So mg sine theta minus f is equals to ma, right? Now, and they are asking us to find, calculate the frictional force acting on the block, coefficient of static friction mu s mu f, right? Now, if object yet rest, so a is equals to 0, and in such a case mg sin theta minus f is equals to 0, and mg sin theta is equals to f, and remember object is at rest position means static frictional force will act, so we have to represent with the static frictional force fs, with the fs. Clear, right? Then next one is fourth question, probably I think it's fourth question. A block of weight 100 kg, sorry 100 Newton, weight 100 Newton, a block of weight 100 Newton lying on a horizontal surface just begin to move when a horizontal force 25 Newton acts on it, determine the coefficient of static friction. That means the object is ready to move. And how much is the amount of, right, what, how much is the frictional force is acting? Obviously if the force is acting in this direction means object should move in the rightward direction only, so friction force will opposite direction, friction will act in the opposite direction, and they are asking us to find coefficient of static friction. Coefficient of static friction means mu s value, they are asking us the mu s value, right? Now this is n, and on, right, along direction of force, direction of force, force sigma f is equals to ma, and chalo, static means a is equals to 0, obviously a is equals to 0, static means, then f is acting in the rightward direction, minus f is equals to 0, f is equals to f s mu n f, right? Mu s n, this formula just now I had explained you, f is equals to mu n formula, and f value they given as 25, and from the diagram n is equals to 100, from the diagram n, oh sorry, from diagram n is equals to 100 Newton, right? Mu s 100, then mu s is equals to 1 by 4, that's it, 1 by 4. Kinetic friction, static friction, sorry, the object is at rest position, so the static friction coefficient value is 1 by 4 or 0.25. This is what is right. Now see here, the fifth question, determine the magnitude of frictional force and acceleration of block M in each of the following cases. This is one of the most important problem. Most important problem. See very carefully. Here 10 kg mass, and here force is acting in the rightward direction 20 Newton. Then given mu k is equals to 0.25, mu s is equals to 0.3, mu s is equals to 0.3. Now let us see sigma f is equals to ma, obviously it is moving in the rightward direction with an acceleration, and normal is acting in this direction, acceleration, and this will be mg, and this will be the frictional value. Understand here one most important point is, that is, first of all, we need to find how much should be the required amount of force I have to apply on the object, then the object can able to move. First point. Then the next point is, see here, the object can move in the forward direction when its static nature will collapse. Right? When its static nature is collapse means when its static nature is, we cross that static nature, then the object can move. So how much is the required amount of force is required to avoid or to break that static nature? That is called as limiting friction. Limiting friction. limiting frictional force, right, which is equals to Fs mu s n. Then Fs value is equals to 0.3 and n value is equals to mg, which is equals to 0.3 into 10 into 10, which is equals to 30. And if we are giving 30 newtons, that is limiting friction value to the system, then only the system can able to move in the forward direction. But see the question here, they are mentioned it as 20 newtons. If we are giving 20 newtons means does the object can move in the forward direction? Because the force value which is sufficient to move the block in the forward direction is 30 newtons, but the applied force is 20 newtons, which is less than the required amount of force, so object would not move in the forward direction. Clearer? Then next problem, let us see second case. Here 10 kg n mg 60 newtons and static friction, and obviously static friction value is 30 newtons, means the object can able to move in the forward direction because the application of force is 60 newtons. So limiting friction value is 30 newtons, up given force is 60 newtons, obviously the object can able to move in the forward direction. But when object starts its journey, you have to consider kinetic friction only, not static friction. Static friction is up to object has to move. Once object starts moving means you have to consider only kinetic friction. Then you can write here by using Newton's second law, 60 newtons in the forward direction, Fk in the leftward direction, then object would get certain amount of acceleration. Clear? Then 60 minus mu k mg or mu k n m a, then 60 minus mu k value is 0.25, 1 by 4, m is 10, g 10, 10 a. Now this becomes 60 minus 25 is equals to 10 a, 35 by 10 a, acceleration is equals to 3.5 meter per second square. I hope you enjoyed the class a lot, and I explained each and every part of the friction, which will really helpful for you a lot. And tomorrow we will discuss some critical problems on the friction concept again. And for daily practice sheets and weekend examination papers, you better to follow our Telegram channel, Physics with Jagan sir. Have a great day. Take care. Bye bye.